Good afternoon, students.
Good afternoon.
Good afternoon, ma'am.
Good afternoon. All of you, please switch on your videos. So many videos are off here. Okay, students. So in the last class, we discussed about the Newton's second law of motion. And we derived a relationship between acceleration and that of the force. And what is the role of momentum in Newton's second law of motion? And we discussed the various applications of Newton's second law of motions in our daily life. I hope all that points are clear, right? Okay. Then Adigesh, state the Newton's second law of motion.
Ma'am, the rate of change of momentum of a body is directly proportional to the applied force.
Okay, the rate of change of momentum of a body is directly proportional to the applied force. And what about the direction of that force, direction of that momentum?
It takes place in the direction that it has.
Okay, it takes place in the direction of the momentum takes place in the direction of that applied force. Very good. Then Isha, mathematical expression for calculating the force according to Newton's second law of motion. Mathematical expression.
Force is F and momentum is M.
Okay, what is the mathematical equation? Equation for calculating the force according to our Newton's second law.
Force equal to M into V minus U by T. That is, force is equal to M into A.
Yeah, that's
A
all.
means
F is equal to, yeah, very good. F is equal to MA. So this is the mathematical equation for Newton's second law of motion. Everything clearly explained by Isha. A is V minus U by T. That is what is meant by A. A is acceleration. Okay, that's all. Then Alan, what about the mathematical unit for force? Mathematical unit. Newton is the SI unit. My question is mathematical unit for force. Tamanna, mathematical unit. Okay, 1 minute, 1 minute. I will give one more chance to Alan. Alan, mathematical equation for calculating the force is F is equal to MA. What is the SI unit of mass? M. SI unit of mass?
Kilogram.
Kilogram. Very good. What is the SI unit of acceleration?
Kilogram meter per second square.
Yeah. So when we are comparing the SI unit of mass and acceleration, we get the expression for mathematical unit of force, that is kilogram meter per second square. Kilogram meter per second square is the mathematical unit for force. And this kilogram meter per second square is equivalent to Newton. Okay, Newton is the SI unit. So SI unit of force is Newton, which is equivalent to that of its mathematical unit, that is kilogram meter per second square. And as we told earlier, force is a vector quantity because it possesses both magnitude and direction. Then the next question to Jairus. Tell me any one application of Newton's second law of motion. Any one application of Newton's second law of motion.
A cricket pitch fielder.
Yeah.
When he catches the ball, he throws his hand backwards to slower the force of motion.
Yeah, a cricket fielder who pulls the hands backward while catching the cricket ball. So why he do this kind of action? Because whenever he pull his hands backwards, the time to reduces the velocity becomes increases. So the velocity of that cricket ball becomes reduces. Whenever the velocity reduces to 0, what happens to the momentum possessed by the cricket ball? It will be also reduces to 0. Thereby, the force exerted by the cricket ball on the hands can be reduced. Okay, because the momentum is directly proportional to that of the applied force. The rate of change of momentum is directly proportional to applied force. So whenever the momentum get reduced or it is decreases, which implies force exerted by that object also will be reduced. So we can avoid the injuries of such cases. Okay, then I need one more application. So that is from Sridev.
One high jumping or long jumping athlete.
Yeah.
When he jumps, there will be some mud or some sheets of
Heap
sand.
of sand. We are using some heap of sand or cushion. The cushion or heap of sand is used while long jumping or high jumping. Why we are using this cushion or heap of sand during the while high jump or long jump?
It increases the time.
Yes, it is increases the time of or increases the time which reduces the velocity to zero. Whenever the velocity reduces to zero, the momentum possessed by that moving body, that high jumper or the long jumper, becomes zero, or the force exerted by him is also reduces to zero. Thereby, he can protect him from this injuries caused by whenever during the time of long jump and high jump. So these are the two applications of Newton's second law of motion. So here we are already covered or discussed Newton's two laws of motion. The first one is Newton's second law of motion. That is, every object is in a state of rest or state of uniform motion unless it is compelled to change that state by an external force acting on it. Then the Newton's second law of motion. From the Newton's second law of motion, we get a mathematical expression for calculating the force. That is, F is equal to ma. It is the product of mass into acceleration. The rate of change of momentum of a body is directly proportional to the applied force, and it takes place in the direction of force. So I hope these two laws are clear to you. Is it clear?
Yes, ma'am.
Okay. So today we are going to discuss Newton's third law of motion. Newton's third law of motion. So all of you write the next heading, Newton's third law of motion. Newton's third law of motion is the most easiest law that we can understand. That this third law is most probably it is occurs in our daily life. Okay, so you just imagine that. I think most of them are possessed siblings. You have sometimes brothers or sisters. At least sometimes you are made by your friends or neighboring friends, neighbors and all. Okay, so you just imagine if your brother beat you or hit you, what will you do back? If you are good students, you will do nothing. You simply sitting and say, no problem, you can beat anymore, once again and all. Otherwise, if you just think you are not at all a good student, then what do you do? Will back. What will you do? At the same instant of time, you beat him back, right? At the same instant of time. That is what is known as Newton's third law of motion. That is, to every action, there is an equal and opposite reaction. So if your brother or sister comes and beat you at the same instant of time, you beat him back or beat her back. So that is what is known as the Newton's third law of motion. Okay. So before stating this Newton's third law of motion, we can explain two types of forces. That is action force and reaction force. Okay. So all of you write a subheading under this topic, Newton's third law of motion. Action force and reaction force. Action and reaction forces. Action and reaction forces. So first of all, we are going to discuss what you mean by action force. Action force. Action and reaction force. Action force. What do you mean by action force? It is the force exerted by one object over the second object. It is the force exerted by one object over second object, or one body over the second body. So while we are discussing this action and reaction force, here we consider two objects or two bodies, such that action force is a force that is exerted by one body over the other body, or one object over the second object. It is the force exerted by one object over the second object. Then, what do you mean by reaction force? Reaction force. Try to form a definition by yourself. Action force and reaction force.
The force exerted by the second object over the first object.
Very good. Reaction force is nothing. It is the force. It is a force itself, but it is the force exerted by second body or the second object over the first object. So action force, it is the force exerted by one object or the first object over the second object. Now we can write reaction force. Reaction force. Reaction force, it is the force exerted by second object over the first object. So the combination of this action and reaction forces are actually known as Newton's third law of motion. So while we are studying this Newton's third law of motion, you just kept these two forces in your mind. One is action force and the second one is reaction force. So first the action takes place. At the same instant of time, the reaction force takes place at the same instant. Okay, action force is nothing. It is the force exerted by the first object or one object. Here we can write it is first object. It is the force exerted by first object over the second object. And at the same instant, the reaction force takes place. Then what is reaction force? It is the force exerted by second object over the first object. Okay. So whenever you heard this term action and reaction, this action and reaction is nothing. It is the force. There are two forces are there. One is action force and reaction force. Okay. And what about their direction? Does they are in equal direction? They are lies along the same direction, action and reaction force?
No.
No,
Opposite.
they are in opposite directions. They are lies along the opposite directions. So you can write the characteristics of action and reaction force. Write the next point. Action and reaction forces are opposite to each other. Action and reaction forces are opposite to each other. And what do you think? Where it takes place? Does this action and reaction forces takes place in the same object?
No.
No. Action takes place on the one object, that is on the second object. The reaction takes place on the first object. So we can write
Ma'am,
yes.
ma'am, to and
Yes.
ma'am, to and ma'am, to and
Action. Okay. Thank you. Action and reaction
yeah,
forces.
welcome.
Okay, all right. Thank you, dear. My God, 2 Ds are there now. Action and reaction forces are opposite to each other. Action and reaction forces are opposite to each other. Or we can say the two forces are takes place in different objects. So action and reaction forces are occurs in different objects. Action and reaction forces are occurs in different objects. They are not occurs in same object, they are occurs in different object. Different objects. So these are the two characteristics of action and reaction force. Okay. Action and reaction forces are opposite to each other. If action is a force that is acting along forward direction, we can say reaction is also a type of force which is acting in the backward direction. And this action and reaction forces are not occurs in same object, they are occurs in the different object. So based on this concept of action and reaction force, Newton formulated the third law of motion. That is what is known as Newton's third law of motion. To every action, there is an equal and opposite reaction. So before that, I suppose you just imagine that if a ball is hits on the ground, okay, a ball hits on the ground, what happens then? It is bounces back from the ground. So can you identify the action and reaction force in this activity? If a ball hits on the ground and at the same time it bounces back. So what is the action and reaction forces here in this case?
And when the ball hits on the ground, action force.
Yes, whenever the ball hits the ground, it is an action force. Then what is the reaction force here?
Opposite when the ball bounces.
Yes, the bouncing back of the ball is the reaction force. Okay, so now we can state the Newton's third law of motion. So based on this concept of action and reaction forces, Newton's formulate the third law, that is, to every action there is an equal and opposite reaction. To every action there is an equal and opposite reaction. Don't need to copy down this entire explanations for the Newton's third law. It becomes more complicated. You just simply understand what you mean by Newton's third law of motion. To every action, there is an equal and opposite reaction. So here in this law of motion, we can see the two terms, action and reaction. Now you have an idea about what you mean by action and reaction. Action is nothing. It is the force exerted by one object on the other object. Reaction is the force exerted by the second object on the first object. That is what is meant by action and reaction. Now you can write these points. Action and reaction are just forces. So in the Newton's third law of motion, we can find the two terms. One is action and reaction. So action and reaction, these two terms are just forces. They are just forces. And these forces are always occurs in pairs. We cannot consider them as single one. They are not in monopair. We are consider them as pairs. Okay. Because if action is there, reaction should be there along with action. So the forces always occurs in pairs. The third one, action and reaction do not act on the same body. Action and reaction do not act on the same body. Normally, we are not beat or pinch ourselves. We are do all these kind of activities on our second body. Okay, so action and reaction do not act on the same body. The next point, action and reaction act on different bodies, but how? It occurs simultaneously. If and only if your action is comes, then only the reaction force is occurs. So action and reaction act on different bodies, but simultaneously. The last point, it's very important. Action and reaction forces are equal in magnitude, but opposite in direction. But they do not produce equal acceleration in the two bodies on which they act, means, but opposite direction. Action and reaction forces are equal in magnitude, and you can simplify this sentence. You can make simple, that is, but opposite in direction. Action and reaction forces are equal in magnitude, but opposite in direction. So under this third law of motion, we made some points about the action and reaction force, because based on this concept of action and reaction force, Newton's formulate the third law of motion. Action and reaction are not just a term, they are forces. They are actually occurs in pairs. They are acting on two different bodies. They are not acting on the same body. They are acting on two different bodies, and they act in simultaneously. And the magnitude of these action and reaction forces are same. For example, if your friend push you with a force of 10 Newton, at the same instant of time, again you push him back with the same force, 10 Newton. Okay. So if 10 Newton force is applied in the forward direction, at the same instant of time, you push him or her back with the same force, 10 Newton. So here the magnitude will be the same, 10 Newton, but it is in opposite direction. One person pushes you forward, then you pushes him or her back in a backward direction. Okay, so here the magnitude of action and reaction forces are equal. They are 10 Newton. Their magnitude are equal, but it is in opposite direction. One force is in forward direction, one force in the backward direction. Is it clear? Out of these three laws, the most simple law, and every students are like to study this third law of motion, because it's very easy to study. To every action, there is an equal and opposite reaction. Now, can you say some examples for the applications of Newton's third law of motion from our daily life? Newton's third law of motion.
When a ball hit the wall gives the reaction and it bounces back.
Very good. Whenever a ball hit the wall, it bounces back from the ball. Bounces back from the wall is an application of Newton's third law of motion. Similarly, have you observed the recoil of a gun? Recoil of a gun. So, is it over?
Yes,
Can
ma'am.
I? Okay. Now write the next heading: applications of Newton's third law of motion. Applications of Newton's third law of motion. First one, we can write bouncing back of a ball. Bouncing back of a ball when it hit on a wall. That is, the ball exerts an action force on the wall, but at the same time, the reaction comes from the wall. It exerts an opposite force on the ball, That's why it's returned back. So bouncing back of a ball when it hit on a wall. The second one, recoil of a gun. Recoil of a gun. Have you ever observed the working of a gun shooting?
Yes.
How it takes place, or how the third law of motion applies in the recoil of a gun.
When we shoot, the bullet goes forward and it will exert pressure from the gun, but this bullet give pressure to this gun too.
Yes, whenever we shoot, we are applying a little force on the gun. The gun is moves a little backward, but at the same time, the bullet is moves forward. Okay. Actually in Malayalam, we are called this shooting of a gun using